Okay, so with any good physics problem, first thing you have to do is diagram it out. So here it is. We've got our two boxes. Box A has a massive, we don't know what that one is. We've got a force tension on this string. That's also, we don't know what that one is either. Box B has a mass of 5 kilograms. We have our force of 40 newtons being applied at a 53.1 degree angle. And both boxes have a mu kinetic of 0.3. And the only other piece of information we have is that the whole system is accelerating this way at 1.5 meters per second squared. Okay. So what we're going to do is we're going to put this in terms of net force. Since there's acceleration going on here, it's constant acceleration, we know we have a net force going this direction of something. We don't know what it is yet, but we're going to find it. All right, and in order to do that, we're going to break this into its component forces. So I'm going to turn this into a right triangle here, like so. Okay, so we have a horizontal force component here and a vertical force component here. This one's going to be cosine because it's the adjacent side. This one's going to be sine. So cosine of 53.1 degrees. Okay, and then it's going to be times 40. That's your hypotenuse. And this one would be 40 sine of 53.1. And I cheated and did these in advance. Okay, so your horizontal component is 24 newtons. Your vertical component is 32 newtons. Okay. Now, the fact that there's an angle here is important. Since some of this is going up, that means some of the force is lifting this box off the ground, which is going to reduce the total amount of friction we're going to get here. So we're going to calculate this force of friction, Fk, and we know that the force of friction is the normal force times the coefficient of friction. And our normal force is the mass of the box times the acceleration of gravity. But in this case, since some of that weight is being lifted up, we're going to subtract the vertical force here. Okay, that vertical force we're going to subtract from the normal force because it's counting opposite. Right? Normal force always goes down. This force is going up. They're going to cancel each other out. So that's 32. And our mu of friction was 0.3. Okay. So this whole thing works out to be 5.1 newtons. All right, so that's the force of friction for this box. We don't know anything about this box yet, but we know the force of friction for this one is 5.1 newtons. Okay, so if we do a free body diagram, we know we have a horizontal force of 24 newtons, right? That's our horizontal component here, pulling the entire system this way. Okay, so that's 24 newtons that way. Okay, and we know we have a counter force this way of 5.1 newtons, right? That's the force of friction. This force of friction is going to resist this motion by pulling the opposite way. And we also have this force of tension. We don't know what that one is. We know it's there. So we're going to list that. Okay. So this is all going to come down to one calculation. Right, and that calculation is everybody's favorite, F equals ma. Right. So this F is actually going to be our net force. Right. And our net force is this force minus these two forces. So we write that down. We've got 24 newtons minus 5.1 newtons minus our tension force. We don't know what that is yet. All right, and that equals our total mass, which is 5 plus our mystery mass, A, we don't know what it is, times our acceleration, which we know is 1.5. Okay, now this one, we don't know what it is, but we do know what it should be, right? Because that force tension, put that right there, that force tension has to equal whatever this force of friction is, which is going to be just like this force of friction. All right, it's the normal force times our coefficient of friction. And we don't know what the mass is, but we do know mu is 0.3. We know gravity is 9.8. And our mass here is just going to be m. It's mass. We don't know what it is yet. All right, so we're going to plug that in there real quick. Okay. Now when we simplify this down, this becomes 18.9, 2.94 m, 7.5 plus 1.5 m. There we go, sorry. Try not to have you stare at the back of my hand the whole time. All right. So we subtract the 7.5 over here. We're going to add this over here, collecting our like terms. Okay, now when this comes out, that tells us that our net force here, our force of tension in this case, is, oh, look at that, 11.4. How about that? Okay, so the force on our box, right, works out to be 11.4. Since we added this to the other side, it's the only force left, right? So our force tension is right there. And to find our mass, we would just divide both sides by 4.44, telling us that our mass is 2.57 kilograms. And there it is. Okay, so you always start with the diagram. Calculate the forces you can find first. Right? We knew we had to find our net force. We found this force of friction. We wrote the formula for the other force of friction and substituted it into F equals ma, which you use for basically everything in this class. Okay, and simplified it out. The last force standing was our force tension. It was the only one we hadn't found. So that force, that mystery force, had to be force tension. And we divided out our algebraic coefficient to find our mass. And that's it. Hope that helped.